Hello everyone. In this short video, we will try to recall the story of Eratosthenes and how he determined shape and size of the earth 2000 years before Christ. So before we begin the video, I will tell you Eratosthenes, he was a famous Greek, ancient Greek mathematician, astronomer, geographer and scholar who lived in the 3rd century before Christ. He, he used simple trigonometric method and his knowledge to determine the circumference of the earth. He used a simple but elegant method to measure the size of the earth, which involved using the angle of the sun's rays and some basic trigonometry. So here how he did it. In this slide, you can see that this is the sun and these are the sun rays, these blue lines, blue arrows. And he studied the phenomena in Sain. Nowadays, the Sain is called as Aswan, city of Aswan. This city of Aswan or Sain is in Egypt. This Aswan lies on Tropic of Cancer. Now, in my previous video, I have told you what is Tropic of Cancer. So, Tropic of Cancer is a line of latitude at approximately 23.5 degree north. There is a very unique phenomenon that happens on this Tropic of Cancer on 21st of June, which is also called as summer solstice. On this day, the sun is directly overhead in the city of Sain, and Eratosthenes observed that on this day at noon, the sun did not cast any shadow. So what does it mean is for this tower in Sain or Aswan, he noticed that there is no shadow for this tower. But he noticed that at the same time, the tower in Alexandria was casting a shadow. So it was casting a shadow, this shadow. Okay. So he understood that the earth is not flat. The earth is not flat, but in fact the earth is curved because it is like this. So the tower was here and the sun rays was falling like this. So it was casting a shadow over here. So he understood that the earth is not flat, but it is curved. So he determined his first objective. He completed his first objective by observing that earth is a curved shape object. Now the second objective was to find out what is the size of this earth. So for this, what he did is he measured this angle. This angle. So this angle is nothing but the angle between the sun rays and this angle is between the sun rays and the vertical tower. So this is the tower. So this angle. So for example, let us assume that this angle is theta. So what Eratosthenes did was he measured the height of the tower, which is say h, and this length of the shadow, which is say s. So this tower was in Alexandria, which was casting a shadow, and Eratosthenes he measured the height of the tower and the length of the shadow, and with simple trigonometric rule he applied tan theta equal to opposite side, which is shadow, divided by the adjacent side, which is the height of the tower. And with this calculation, he found out that the value of this angle is nothing but 7.2 degrees. Now he also did one more observation. He measured the distance from Syene to Alexandria. That time there was no unit available like meter or kilometer. So he used an ancient Greek unit called stadia. Stadia is nothing but length of a stadium. And he found out that the length or the distance between Alexandria and Syene is 5,000 stadia. So now he has two values, the angle value and the distance between Syene and Alexandria. So the next thing for him was to calculate the total distance, which is nothing but the circumference of the earth. So here how he did it. So he knew this angle, which is 7.2. So obviously this angle will also be 7.2 because these are the opposite angles on the parallel slide. So if these are the two parallel sides and if this is a third line, then this angle will be equal to this angle. So he knew that this angle is 7.2 degrees and this distance is 5,000 stadia, this distance. So by using this logic, he found out the total distance. Total distance means this whole distance, which is nothing but the circumference of the circle, this distance, starting from here and going around the circle up to this point. So this is nothing but the circumference of circle, which is circumference of earth. So he could find out the distance and he knew that this total angle is 360 degrees. So what he did is 7.2 degree for angle 7.2 degree, the distance was 5,000 stadia. So for 360-degree angle, what will be the total distance in stadia? Suppose this distance is x. So he found out that the x was 250,000 approximately stadia. Okay. So surprisingly, this estimate was accurate considering the limitations of the technology available at that time. Now, the modern technology nowadays, they use more precise measurements and found out that the Earth circumference means this 2 pi r, total distance with modern techniques is found to be 40,075 kilometer. Now, if Eratosthenes was to convert this distance, he has to multiply this stadia value by approximately 160 meters because one stadia equal to 160 meters. So the modern technique found out that the circumference of the earth was 40,075, which is very close to the circumference found out by Eratosthenes, which was 39,375 kilometers. So now you see that how accurate it was, considering that it was done 2000 years before without any technology, without any modern techniques. So that's why it is said that Eratosthenes' method for measuring the Earth's circumference was a remarkable achievement, and his work helped to lay the foundation for modern science and geography. I hope this video is useful. You will find it useful, and now you will be very clear with the story of Eratosthenes and how, with his simple method and knowledge, he found out the shape and size of the earth 2000 years before Christ. Thank you.